Now let's see the program that the algorithm that we have come up with. I have uh, I have that available as a function here. We call that clusters, and let's see if that manages to produce what we are looking for. So let's say we have clusters, and we provide the inmat that we have been working with. Although it's simple, we'll see if that works or not. So that's 100,011, and we know it has two clusters, and the answer is 2. So that sounds good. Let's check a trivial case, which is all ones. That means we should have just one single cluster, and the answer is 1. Okay, so the program that I have here, that's working. At least that's what we feel. So let me explain this program and how this is getting us to the results. So this program has 4 major parts. So let's say this is the first one, and here we are essentially defining CMAT, or we call that count mat here, and then here we are defining all the different possible moves, and here we are applying all these different moves on inmat and countmat, and bringing all the different adjacent numbers in countmat into one single number. And finally here we are looking at the different non-zero elements in countmat after it has been modified, and finding out the number of clusters. So obviously the core of the program is this part, and let me start with this. So if you remember from my explanation of the algorithm, you could see that we had to apply all different possible moves. 4 of them are here. So this is the for loop which is taking us through that, and we are applying this function circ shift to both countmat and inmat, and storing them as C and IC respectively. And here is what we explained, that we compared inmat and IC, element by element comparison, and same with countmat and C. And I would like to point out here that although this looks very symmetric, this greater than sign has precedence over ampersands. So countmat greater than C, that's being carried out before the rest could be done. So remember that it's not like inmat and IC and countmat together greater than C. So once this thing is done, then that's being applied. So here is where we actually set different elements in countmat into one single element, one single number. And I would like you to think about one small thing here. What if we changed this greater than in these two cases into less than? Would that change anything? If you understand how this thing is going, maybe you'll be able to work that out, and for sure you can play with it and you'll see what result you get. Once we have these loops, you see that we initially stored the count mat into something else called old mat, and we repeat this loop till this count mat and old mat are the same. And the way we check that is quite interesting using this function all. So you have you have this all, which when applies on a two-dimensional array, it returns a one-dimensional vector, and when it applies on a one-dimensional vector, it gives us a single number. So this is a cool way of comparing two different matrices or two matrices and see if we have the same matrix that we are working with, or they're still different. By the way, the same kind of technique stands for this sum function as well. So we applied sum on two-dimensional in mat, and by the way, this is part of the this setting the count mat with different values. So we start with sum operated on in mat, and that's a two-dimensional array in mat. So sum operated once, that gives us a one-dimensional vector, and when you operate sum again, we get a single number, and that happens to be the sum of inmat, all the different elements in inmat, because all the elements are ones, but otherwise it would have been something different. So this is fairly simple. You can follow this part and see how we are setting different numbers into in countmat. And this is the other part where we define all the different moves under shifts, and it's a two-dimensional array. So you have the first row as 1 0 minus 1 0, and the second row as 0 1 0 minus 1. And you see in this for loop, when this variable move goes through the two-dimensional array shifts, it reads it from the left as 1 0 0 1 minus 1 0 0 minus 1. Those are the four different moves that we are looking for, and when we apply, we take the transpose of that, and that's how short shift works. That's a tongue twister. Okay, so I guess with the previous explanation of the algorithm and this program in your hand, probably you'll be able to play with it a bit and understand how we can identify these clusters. And don't forget to play with the first algorithm as well and come up with a different program on your own. So I hope this was helpful. I'll see you later on a different exercise. Bye.